Solving linear equations. In this section, we're solving linear equations. Linear equations mean they're first degree equations, so my variable is raised to the first degree. Equations, of course, mean it has an equal sign. And to solve it means to find a solution. A solution is a value that makes the statement true. In order to solve a linear equation, our objective is to isolate the variable. We want to get x by itself. We want to get x by itself, and when we look at this equation, x plus 5 equals 7, if they're actually equal, think of this as a scale, they would be balanced, right? They would weigh the same. And if our objective is to get x by itself, it means we have to take 5 away from this side. So if I take 5 away from one side of an equation to keep it balanced as a scale, if I took 5 pounds off one side, I would have to do the same to the other side. So whatever I do to one side of an equation, I always have to do to the other to keep it equal, to keep it true. So if I subtract 5 from this side, I get x equals 7 minus 5 is 2. X is equal to 2. We could check this to see if it's true by plugging it in to the original equation. 2 plus 5 is equal to 7. My left side is equal to my right side. This is true. Therefore, this is a solution. A solution is a value that makes the statement true. That's important because sometimes we'll get an x value and we'll plug it back in and it might not check, might not make the statement true. Therefore, it would not be a solution. So in this example, we have a long string of terms. So it looks a little bit more complicated, but it's actually not. What we need to do is combine our like terms on each side of the equation to make this a little bit more manageable. So we're looking at my left side of the equation, and we have 4x and negative 7x, which gives me a negative 3x. And on the right side of my equation, I have negative 15 plus 2, so I'll have 9x, and when I combine these, I'll have negative 13x. My objective is to get x by itself, and in this example, we have x on both sides of the equation. I would suggest you get rid of one of the x's, and I would suggest you get rid of the smaller x term. So I have a negative 3x over here and a positive 9x. I would say let's get rid of this negative 3x by adding 3x. And that'll cancel out. 3 minus 3 is 0. Whatever I do to one side of the equation, I have to do to the other, so I'm going to add 3x over here under its like term. Those will be gone. I will have 3 is equal to 12x minus 13. My objective is still to get x by itself, right? We want to isolate x. We want to get this x term alone, or rather this x variable. So that's a good point. Let's isolate the x term. So I'm going to have to add 13 to get 12x by itself. Whatever I do to one side, I have to do to the other. So I'm going to have 16 is equal to 12x. Now I can isolate the x variable. Right? Now I could get x by itself here. So to isolate this x variable, we want to get rid of this 12. We do it by the opposite operation. This is 12 times x. So in order to get rid of it, I want to divide by 12. 12 divided by 12 will give me 1, and 1 times x will give me x. I'll get x by itself that way. So if I divide the right side by 12, I have to divide this left side by 12. So I have 16 twelfths is equal to x, and I can reduce that. 4 goes into the numerator 4 times, and 4 goes into the denominator 3 times. It looks like my final answer is 4/3. I divide the top and the bottom by 4 to reduce that. So let's look at this example. In this example, again, it's a little bit different. We have parentheses. So we want to remove those parentheses. So we want to distribute to remove parentheses. So in this case, you want to take what's on the outside, which in this case is just a negative or -1, and multiply it to the values on the inside. So I'm going to have 5x minus 2x minus 2 is equal to x. Well, here all I have nothing outside. There's really no need for these parentheses. I could multiply the 1 that's on the outside, 3x minus 5. So now I no longer have parentheses, but I do have a string of terms here. I could combine my like terms to make this a little bit easier. Combine like terms on each side. So over here it looks like 5x minus 2x will give me 3x. And over here, x plus 3x gives me 4x. So I've combined all my like terms on each side of the equation. Now I want to get x on one side. Right? I want to get x on one side. I always say I like to get rid of the smaller x. So in this case, the smaller x term would be the 3x. So I'm going to want to subtract 3x from both sides of the equation. And that's going to leave me with, those are going to be gone. I'm going to have -2 is equal to x minus 5. And now I want to isolate the x term, which in this case, this would be the x term. So I want to get that by itself. So I want to add 5 to both sides of the equation. And I'm going to end up with x is equal to 3. If I had a coefficient in front other than 1, I would isolate the x variable, and that's usually by a function of multiplication or division. I isolate the x term. That's always an operation of addition or subtraction. And then, of course, we could check the solution by substituting it back into the original, which I'll leave for you to do. So here's another example. Maybe you want to pause it and try this one on your own. If I follow the procedure we set forth before, we would just remove our parentheses first. So I take what's on the outside of my parentheses and I multiply it to the terms inside the parentheses. So that would leave me with 3 minus 8x plus 10. And over here I'm going to have negative 3x minus 3 plus 4x. So I no longer have parentheses. Now I can combine my like terms. Over here I have a lot of like terms on the left side. So it looks like I'm going to have negative 8x. And then when I combine this, it looks like plus 16. 10 plus 3 plus 3. And over here, it looks like I'm going to have 9x and 4x, which will give me 13x. Oops. And that minus 3, this will give me 10x. I have 3 like terms there. Now I have x's on both sides of the equation. I like to get rid of the smaller one, so I'm going to add 8x. I'm adding because this is a negative 8, so I want it to negate. So it looks like I have 18x minus 3. I want to get my x term by itself, so I'm going to add 3 to both sides of the equation. I want to isolate my x variable. This is attached by multiplication. So in order to get rid of it, I'm going to divide both sides by 18. X is equal to 19/18. This problem looks relatively simple. Why don't you try it on your own? Hit pause and check it out. And you'll see something peculiar happens with this problem. As I approach this problem, I see it has parentheses, so I know to remove my parentheses, I'm going to have to distribute. So I'm going to have 4 plus 3x minus 6 is equal to 3x minus 2. I want to combine my like terms. On this side, it looks like I have a 4 and a negative 6. So I'm going to have 3x minus 2 is equal to 3x minus 2. Well, this looks suspicious. If I subtract my x's, I have x's on both sides, what's going to happen here? I'm going to end up with negative 2 is equal to negative 2, which is a true statement. But my objective was to solve for x, and I no longer have an x variable. What happened here, if I'm looking for a solution for x, what does x equal? No matter what value I put in for x, it'll be true, because my x's cancel out. So if we go back up here and we look at this problem from here, where we see the left side is exactly the same as the right side, we'll notice no matter what value we put in for x, 3 times 5 minus 2 would be equal to 3 times 5 minus 2. 3 times 6 minus 2 would be equal to 3 times 6 minus 2. No matter what value I substitute in for x, it'll create a true statement. Therefore, all values of x are a solution. There are infinite solutions. So I would put x is equal to all real numbers. So how do I know x is equal to all real numbers? I lose my x variable, but I'm still left with a true statement. And you could go back and see where this occurred, and you could always reassure yourself that your solution is correct. Let's look at this example. In this example, I have 5 plus 6 times x minus 1 is equal to x plus 11 plus 5x. I want to solve this equation. I want to get x by itself, so I want to distribute to remove my parentheses. So I'm going to have 5 plus 6x minus 6 is equal to x plus 11 plus 5x. I distribute to remove my parentheses. Now I can combine my like terms. So I have 5 and negative 6. So I'll have 6x minus 1 is equal to 6x plus 11. I have x's on both sides of the equation. I like to get rid of my smaller x, but in this case they're exactly the same. If I do minus 6x minus 6x, I'm going to end up with negative 1 is equal to positive 11, which is not a true statement. And I lost my x variable again. So what does x equal? Well, in this case, no matter what value I put in for x, if we look up here, no matter what value I put in for x, 6 times 2 minus 1 is equal to 6 times 2 plus 11. No matter what value I put in, I'll always have a false statement. It'll never be a true statement, and only true statements are solutions, so therefore there is no solution to this equation. So the two scenarios that you could run into is you lose your x variable somewhere and you're left with a true statement. That means that x is going to be equal to all real numbers. Or you lose your x variable and you have a false statement. If the statement is false, there is no solution to this equation. Let's try two more examples. So why don't you take a look at these two examples? Pause this video and try solving them. I'm going to start solving them now. So I have parentheses. I want to distribute to remove the parentheses. I distribute the 2. I get 6x minus 14. No parentheses over here. Now I want to combine my like terms. So it looks like I have 4, negative 14, and 1. So I'm going to have 6x negative 10 plus 1 would be a negative 9. And here I have a 6x minus 9 also. I have x's on both sides of the equation, but really right here I could see something. I have 6x minus 9 is equal to 6x minus 9. I know what's going to happen, but let's follow through. Minus 6x minus 6x, I'm left with negative 9 equals negative 9, which is a true statement. I no longer have my x values. I know x is equal to all real numbers. In this next example, I want to distribute my negative 3. So I'm going to have a 2x plus 12 plus 3x is equal to 6 minus 3x minus 15 plus 8x. I want to combine my like terms. Here I have a 3x and a 2x. 5x plus 12 is equal to 5x minus 9. I want to subtract 5x from both sides of the equation. I'm left with 12 is equal to negative 9. This is a false statement. I no longer have an x variable, so there is no solution to this equation.